Okay, so this is part 2 for integration by parts. I've got some examples I'll work through with you all here. I've got an integral x times sine of x dx. Again, if you try any substitutions that we know, any of the fancy integration tricks we've learned along the way, none of them are really going to work here. So kind of a good sort of like red flag that we're going to be using integration by parts. You typically have like a product of functions, and that product of functions, you can't really do any u substitution to really come up with an antiderivative. So as I mentioned before, the things that you need to figure out first, you need to figure out what is u, or what do we want to define as u, and what is dv. Based on what we define those things as, we need to figure out what du is and what v is. So first find the blue stuff, or choose what the blue stuff is. Based on that, we'll find what the red stuff is. Again, our hints are we want dv to be something that's rather simple to find the antiderivative of, and we also want u to be something that gets less and less complex as we take more and more derivatives. So here it seems like if u was x, when I take that derivative I get a constant, and that's good, because then what that means is down the line I will have less variables, or you can think of it as fewer functions multiplying together. So I'm going to let u equal x. The derivative of that would be 1 dx. So that takes care of x. Now that means the remainder here has got to be dv. dv is going to be sine x dx. Okay, I've got to integrate this thing. The integral of sine of x dx is minus cosine of x. That's because when you take that derivative, that'll give you a positive sign. Okay, so just to recall the pattern for integration by parts, it's uv minus the integral of v du. Okay, so we chose u to be x, so this will be u v minus the integral of v du. Okay, not too bad. Let me go ahead and clean up the signs there, the signs with the g, not just s-i-n-e. So minus x cosine of x plus the integral of cosine of x dx. Okay, cool. We're at a point where we can just take the integral of this. Now I just want to caution you, with a lot of integration by parts problems, you have to use integration by parts more than once. So we're pretty fortunate here, we can just take that antiderivative. So we get minus x cosine x plus sine of x plus c. And if you're at all curious, if you have the right answer, you can take the derivative of that thing. It's a good practice. Take the derivative of this thing, make sure that you end up with x sine of x. The next example here, I've got x squared e to the x. And so, same story. We need to figure out what should we define as u, what should we define as dv. Based on how we choose those things, what will du equal and what will v equal. Okay, this one almost looks exactly like the first example with just plain old x e to the x. So maybe that's a good idea. Let's let u equal x squared, and by good idea and that I mean the approach we took the first time. We let e to the x be dv, because that was relatively simple to find the integral of, and it doesn't really make things more complicated when we take that integral. And when we have x squared, du is going to be 2x dx. So I still have a variable, but it's simpler in terms of how many functions and maybe to what power those functions are. that are multiplying inside my integral. So now when I apply integration by parts, that's going to be u v minus the integral of v du. Okay, so now we are in new territory. Like I mentioned, we're going to have to do integration by parts again. So I'm going to factor out that 2. Now we have x e to the x dx. So you may not notice, but this actually right here is the very first example we looked at in the last video, on the tail end of that video. So we already know how to do this one. We're going to have to do integration by parts again. So from here, I'm going to start with a new u, a new dv. Based on what I choose for those, I need to figure out du and v. So we already know how to approach this one because, as I mentioned, this was the first example. I'm going to let this be x, then this will be 1 dx, I'll let this be e to the x, and that integral is itself. Kind of nice. Okay, so putting all that together, this stuff is still all there. So x squared e to the x minus 2, and I'm just going to open a really big bracket here. So now I need to put in uv minus the integral of v du. Okay, so I still have one more integral to take, but it's a relatively simple one. And I'll go ahead and distribute that 2 there. And the integral of that is just e to the x. Minus and minus makes plus. Don't forget that plus c. There's our answer. And again, if you define this as y, figure out what y prime equals. You'll have to use a couple of product rules. In the end, as long as you do your derivative rules correctly and your algebra is on point, you should end up with just x squared times e to the x. Okay, I'm going to stop here and then put the last few examples on another video.